Hey everybody, I'm going to do the first problem on the midterm. So we have a soccer player kicks a ball off a 30-meter high cliff. She kicks it upward at an angle of 30 degrees above horizontal with an initial velocity of v0 equals 14 meters per second. This is just one of the four different versions, so I'm just going to do this one. You can fill in the numbers for the version that you had. So we've got a cliff here. Cliff is 30 meters high. And she kicks the ball 30 degrees above horizontal. So we'll call that theta. And the initial velocity is 14 meters per second. Okay, so I know something about the y direction, right? I'm going to use a coordinate system right here. Right at the edge of the cliff, so that my y initial is going to be 0. And same with my x initial. Just because I have the coordinate system there. So my theta is 30 degrees. My v0 is 14 meters per second. And my y final, just y, is going to be negative 30 meters. So with this coordinate system, if my y0 is 0, then the ball is going to go down 30 meters by the end. So that'll be my y final here. And I think that's all the information that we know initially. Okay, so the first part of the problem is asking for how long it takes the ball to land. So we're looking for time, right? So the first thing I'm going to do is turn my v0 into v0y and v0x, so I can do a little trig there. The x direction is going to be adjacent to the theta that we know, so adjacent goes with cosine. So v0x is v0 times cosine theta. Basically, cosine theta is equal to, I shortcut it a bit, right? Cosine theta is equal to v0x adjacent over hypotenuse, which is v0, and then I just multiply by v0 to get this here. So I know my v0y is going to be v0 sine theta. Same reasoning applies there. Okay. So since I know more about the y direction, right? If I knew how far it went in the x direction, then I could use my x direction equations, which are here. This one here. But since I don't know anything about the x final, I know x0, but I don't know x final, I'm going to have to use this fourth equation, the y equation with a t in it. So let's write that one down. Y equals y0 plus v0y t minus 1/2 gt squared. Okay, so I know a couple things. One, my y0 I set to be 0 meters, so I can cross this out. That goes to 0. And let's see, I know y final. I know v0y, just found it with my trig. And I know g. So the only thing in this equation that I don't know is t. Unfortunately, we're going to have to do some quadratic formula, but that's okay, we can do that. So I'm going to get everything over to one side. So solve to equal 0. So negative, I'm also going to rearrange the order, because this I want to have first with the t squared in it. So minus 1/2 gt squared plus v0yt. And now I'm going to minus the y over minus y. Okay, so now for my quadratic formula, this is A, this is B, and this is C. So I can set up my quadratic formula, which I included on the formula sheet right here. So time equals negative v0y plus or minus square root of v0y squared minus 4 times negative 1/2 g times negative y. Okay, so that's the square root, and then divide by 2a. So 2 times negative 1/2 g. All right, great. So now I can do a little simplification, right? I have these 2's and 1/2s and the 4 and 1/2. So now let's rewrite that. T equals minus v0y plus or minus square root v0y squared. So minus 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 turns into a minus, right? 3 minuses. Negative 2gy over 2 times negative 1/2 is just 1, so it's negative g. All right. So I think I can plug in numbers here. You have to be a little careful. Remember, v0y is not equal to v0. v0y is v0 times sine of theta. So with these numbers, let me do some calculations. I've got 14 times sine of 30 degrees I have to switch to, sorry, to degrees. Okay, 14 sine 30 degrees is 7. I suppose I should have known that because it's a 30, 60, 90 triangle in this case. So v0y is 7 meters per second. So I'm going to use that in here. So I've got negative 7. I'm just going to try plus first. Plus square root of 7 squared minus 2 times 9.8 times my y final is negative 30. Okay, so that's the square root, and then I'm going to divide that all by negative 9.8. So you have to be pretty careful with all your negative signs here. Okay, I get 1 point. So this time was negative 1.86. seconds. So clearly that's not the time that we want. That's the time back in time before she kicked it, where it would have been at negative 30. So that's sort of the nonsense answer. So clearly I want the negative sign for the plus or minus instead of the positive sign. So if I do that, I get 3.28 seconds. Actually, 2.29. And that is the answer for number 1, part A. So let's do part B quickly. Part B was pretty easy once you figured out part A. So it's asking for how far in the x direction the ball goes. So I'm going to use the second equation here. X equals x0 plus v0x times t. So now we know v0x and we know t, so we can find x, right? x0 is just 0. So x is going to equal, remember v0x was v0 cosine theta times time. So now we know v0, we know theta, and we know time, so we can plug this into our calculator. Let's see. v0 is 14 meters per second times cosine of 30 degrees times our time, which was 3.289 seconds. Okay. So our x is 39.87 meters. All right, and that's it for problem 1. Next I'll do problem number 2.